Hi, and welcome to Module 15. I'm your professor, Dr. English Dowdell. Now, we're entering the review phase of the course. So, this week is not about creating anything new, and it's not your final submission week. That's going to be next week. But instead, Module 15 is basically like your opportunity to review, refine, and strengthen the work that you've been building step by step through your milestones. Now, by this point, you should already have the major components of your final project, your IPO chart, your modular design in the form of your hierarchy chart, your flow chart, your pseudocode that may include some decision structures and loops and things like that, and then your test plan. Now, each piece has been created gradually, across the different milestones. Um, so you've already built the foundation. So now it's time to really kind of just pull everything together, check for gaps and apply any kind of feedback and prepare for next week's final submission. Now, there's no final project deliverable this week. There is a discussion post, and we'll talk about that in a bit. But this week is strictly for review and cleanup and improvement. Now, one of the most important things that you can do in Module 15 is to go back and carefully read the final project specifications. Make sure that you understand every requirement and verify that your milestones align with what the final project is supposed to achieve. Now, next, I strongly encourage you to review all of the feedback that I gave you on your milestone submissions. Now, every assignment this term has really been building your final project. And any comments that I may have made were designed to help you spot any kind of issues early, strengthening your logic, and then adjusting your design before the final submission. So take the time now to apply that feedback so that your final project is accurate, consistent, and complete. Now, you also have an optional Python enrichment activity this week. This isn't required, but if you're interested in seeing how pseudocode and modular design translates into actual executable code, it's a great chance to explore and deepen your understanding. So again, this week is about refining, reviewing, and getting organized. Now, next week is when you'll officially like submit your final project and your final written summary. But right now, your focus is to simply strengthen what you already have created. Now, the objectives for this week is, like I said, to integrate sequence, design, and repetition structures. Look at how maybe you have integrated those into your pseudocode, into your design, and then again to apply that modular program design. Look at how you've applied it, see if there's any room for improvement, and then again to complete that logical solution for the complex programming problem. This is again where everything is going to connect. Everything that you've been doing is going to connect. So like I said, the goal for this week is to really ensure that you've got all of the logic in your final project from beginning to end. And that means identifying like your inputs, defining your processing steps, structuring your decisions and your loops, and organizing your data and designing your inputs or your outputs clearly. Now, again, this isn't about writing code. You're not going to be writing any new code, unless you need to clarify anything that you've already have, but this is about showing clear thinking, your ability to solve problems by basically breaking them into logical processes. And that's what really this course has been about, breaking things into logical processes. So I want to do a little quick refresher, on some of that. So one of the things we talked about was sequence, how important sequence was. And this is basically like our step-by-step in order execution. So remember, every program is going to require a solid sequence, and that's going to show your start, it's going to show your input, your process, your output. Sequence forms basically like the skeleton, of your project. Now, remember also we talked about decision structures. So these define the say the fork in the road. Okay, whenever your program say has a choice or a condition, you use if statements or validations or maybe even using like menu selections. Those are your design structures. And then remember, loops handle repeated behavior. So it helps us to what iterate through arrays. It asks for input until valid. So, is it this? Is it this? And we just keep checking until, the input is valid. It allows us to process multiple items. So if you've got multiple items, it'll allow you to go through like that array list of items. If something repeats, remember, if something repeats, then it belongs in a loop. Now, I did want to spend a little bit more time on this week, this week's lecture on modular design because this is one of the probably the most important skills in programming and one that makes or breaks, say, your final project. So basically, what is modular design? So modular design means breaking your program into small, well-defined parts. And we've had a lot of practice with this, where each part or module performs one specific job. So instead of one big giant block of logic, you divide your program into organized modules such as get user input, valid input or validate input, calculate total, find highest score, display results. Each module does one single job. And what this does is it avoids clutter, it avoids confusion, and it makes logic a lot easier to follow. Now, why does modular design matter? So think about real programming or real software development. No one is going to write 500 line program like in one spot. It's impossible to maintain something like that. And it's too easy to break, and it's going to be too hard to debug. So modular programs, again, they're easier to understand. They're easier to test. They're easier to reuse. They're easier to modify, and they're easier for someone else, say, to pick up and follow. So you want your final project to read like a well-organized book, not like a jumbled, say, notepad. So how do you know when you need a module? Okay, so you should ask yourself, is this section of logic doing more than one task? Okay, does the logic appear, more than once? Is my main module getting too long? Would a programmer benefit from having this separated? So if your answer is yes, then you know it's time to create a module. So using that logic or using those questions, so if we think about modular, how we would create modules. So like if we didn't have modular design, in our main, say, program, we'd have, to ask for the scores, say, for instance, we'd have to add them up. We'd have to compute the average. We'd have to determine the letter grade. We'd have to dispute the output. And then we'd have to repeat for another student. So we'd have to do this process over and over and over again, in this one module. And all of this, if we squeeze this into one giant block, this is where we're not using modular design, okay? Putting all of this into one giant block. That's just too much. Like I said, it's harder to debug, it's harder to read, it's harder to understand, okay? But when we have modular design, what we do is we have all these different modules that say our main module will call. It'll call the get scores module. It'll call the get calculate average module. It'll call the get letter grade module. It'll call the display results. So each of those would be separate modules that are handling, say, a single task. And all we do is we just call it, and so your project should follow this kind of pattern, okay? So, what should be its own module? Well, common modules, like for maybe your project might be, input collection module, input validation, maybe a menu display, maybe some calculation, maybe you might have a searching and sorting module. You might even have like where you display like formatted output, or working with arrays, or any kind of repeated action, could be its own module. Any chunk of logic that you feel like should be a standalone process. Okay, that's what you would make a module. So basically, the golden rule for module design here is, if your pseudocode in your main module is longer than 10 to 12 lines, then what you need to do is break it up into modules. So think of it as different, like puzzle pieces, okay, that you put together, but each puzzle piece can work on its own. Each puzzle piece represents like one particular task. So when you're reviewing your project before you turn it in, I want you to make sure that you're showing some clear modular structure. And we kind of talked about, again, we went through this, and I gave you feedback on this. So when I grade, what I'm looking for is, I'm looking for clear module names. I'm looking to see that each module has one purpose. I'm looking for the logical flow between the modules, proper use of parameters, or maybe even return values if that's applicable, and then the main module that simply basically coordinates the entire system, by calling each one of those modules. Um, just think about the project. It's not about getting the answer, it's about showing structure. That's what I want to see. And an organization that's worthy of like real software analysis. Okay, so I want to see, like, what we've done is we've broken it up into the different modules, and then we call that main module. So that's what I'm going to be looking for. Now, the discussion post is the only thing that you really have to do for this week as far as submitting, I should say, work. And it should be simple, and hopefully it'll be helpful to you. So what I want you to do is, I want you to basically, share your topic. You all should have sort of like the same topic, but I just want you to just, verbalize your topic, your current progress. And then if you have specific feedback that you want to get, or you have a question that you want to ask, or something like that about the project, or how someone else maybe handled something, that you can post, so like maybe, once you talk about like your project and maybe your topics, and you talk about the different modules that you have, then maybe you can pose a question to say, like, does your module structure make sense? To everyone else. If you've included some kind of loop or repetition, you can ask, does do your peers think that you have applied your loops correctly? Um, and then maybe if you're listing out, like I said, list out the different modules that you're going to be including in your project. And then you can ask, see if maybe someone can suggest, that you can add another module, but just something that you can get some kind of feedback. I want you guys to kind of, help each other as far as the project, and when you're posting it, you're posting like either your initial, information about your topic and your different modules, or even if you're posting like, responses to your peers, don't be vague, help your classmates, help you, ask them the questions, specific questions, and then respond, and help them out. Okay. So you've developed some real skills this term, skills that will really translate into real world problem solving. So your final project is basically a chance for you to bring everything together, and then show this mastery. So what I want you to do is take your time, go through it. Like I said, look at any reviews that you've got, any feedback that you've got. Just make sure everything is kind of cleaned up. Look at the checklist, go to the final, project description, and make sure that you've included everything that you're going to be submitting. I want you to really lean heavily into modular design. I want you to really ensure that you're using, from what I've seen, most of you are doing that, but really make sure that you're embracing as far as modular design, because that's going to be important. And if you hit a roadblock, make sure that you email me before the deadline. So I want you to finish strong. I want you to have a good week this week. And I want you to realize that you've got this.